the problems do get tougher. Let's solve for x. The square root of 2x minus 1 plus x is equal to 8. Since I have an even index, I do have to worry about restrictions. So I need to say that the radicand 2x minus 1 is positive, or 0, which means that 2x minus 1 is greater than or equal to 0. Add 1 to both sides to get 2x is greater than or equal to 1. Divide by 2 to get x is greater than or equal to 1/2. So the values of x that we pick must be greater than or equal to 1/2. Now I want to isolate the radical. That means I need to get the square root by itself. But what keeps the square root from being by itself is this x. So to get rid of an x, I need to subtract x from both sides. So I would have the square root of 2x minus 1 plus x minus x is equal to 8 minus x. The x's will cancel here, so I'm left with the square root of 2x minus 1 is equal to 8 minus x. Now the radical has been isolated. Once I get the radical isolated, I need to square both sides. So I square the left member and I square the right member. The square will eliminate the square root, so on the right, on the left, I'm left with 2x minus 1. So we have square root of 2x minus 1 squared on the left. The square will eliminate the square root on the left, so I'm simply left with 2x minus 1. Now on the right, I have 8 minus x quantity squared. Well, the exponent 2 tells me to use the base as a factor 2 times. So 8 minus x quantity squared is 8 minus x times 8 minus x. I need to multiply this out using the 4 method. 8 times 8 is 64. This will be a negative 8x. This is a negative 8x. And a negative 8x plus a negative 8x is a negative 16x. And finally, the negative x times the negative x is positive x squared. So when I square 8 minus x quantity squared, I get 64 minus 16x plus x squared. Anytime you're squaring a polynomial expression, be very careful that you write it out and expand it completely. So now we have isolated the radical. We've isolated the radical. We've also eliminated the radical. So we have eliminated the radical. We are left with a quadratic equation. I know it's quadratic because my largest exponent on a variable is 2. If you have a quadratic equation, you want to set everything equal to 0 and factor it. So I'm just going to turn it around first and write it as x squared minus 16x plus 64 is equal to 2x minus 1. Now since I want the right member to be 0, I need to add a negative 2x and a positive 1 to both sides. So I add a negative 2x plus 1 to the right side. I also have to add a negative 2x plus 1 to the left side. So I'm left with x squared minus 18x plus 65 is equal to 0. Negative 16 plus a negative 2 is negative 18. 64 plus 1 is 65. Once you get your equation in standard form, then you try to see if you can factor it. I'll just rewrite the problem. X squared minus 8x plus 65 is equal to 0. And then I factor it. Well, notice this tells you your signs will be the same. This one tells you the signs are the same. This one tells you the signs will both be negative. And so I know I've got both negative. Now I ask myself, how can I get 65? Well, one way is 13 times 5. And 13 times 5 happens to work. X times x is x squared. Be a negative 5x plus a negative 13x, which is a negative 18x. And then a negative 13 times negative 5 is positive 65. Now we set each factor equal to 0. X minus 13 is equal to 0. X minus 5 is equal to 0. Because that's the strategy for solving quadratic equations, by factoring. You factor, then you set each factor equal to 0, and now you solve each resulting linear equation. Well, if I have x minus 13 is equal to 0, then what I need to do is to add 13 to both sides to get x is 13. If I have x minus 5 is equal to 0, I need to add a positive 5 to both sides to get x is 5. So I get x is 13, or x is 5. So I get two possible solutions. Both of them must be checked. You must check both solutions. Okay, let's check x is equal to 13 first. Now when you check, you substitute into the original. You substitute into the original. The original was the square root of 2x minus 1 plus x is equal to 8. I'm substituting in 13. So I replace x by 13. So I have the square root of 2 times 13 minus 1 plus 13 is equal to 8. See, everywhere I have an x, I put in 13. Well, 2 times 13 is 26. 26 minus 1 is 25. So I have the square root of 25 plus 13 is equal to 8. The square root of 25 is 5. So I have 5 plus 13 is equal to 8. I have 18 is equal to 8, which doesn't check. So 13 does not check. So mark it out. It's not a solution. Now let's check 5. So again, I write down my equation. Square root of 2x minus 1 plus x is equal to 8. I replace x by 5. So I have the square root of 2 times 5 minus 1 plus 5 is equal to 8. Now 2 times 5 is 10. 10 minus 1 is 9. So I have the square root of 9 plus 5. Square root of 9 is 3. 3 plus 5 is 8. So 5 checks. Since 5 checks, I go up and I circle the answer of x is equal to 5. So x equal 5 is the solution. Since the check is so vital to solving equations involving radicals, I want you to get used to using your calculator to serve as a rough check. Now, your calculator may not give you the exact answer, but should keep you from making a major mistake. If you do not have your calculator with you now, go get it, and I will show you how you can check your answers using a graphing calculator.